Hi everyone, I'm going to continue on with the problem we left off with in the last video. So we were going to graph y equals -2 cosine 4x. We said that the amplitude is 2, but because of that negative, instead of starting at the max, I have to start at the min. So my graph is going to be flipped over the over the x-axis. And our period is pi over 2, meaning I'm going to complete one entire cycle in pi over 2 radians, which means I want to put my intervals in, make my intervals pi over 8, so that all of my key values happen every pi over 8 radians. So if you divide pi over 2 in half and then divide it in half again, that will give you those pi over 8 sections. Okay. So remember, the pattern is max 0 min 0 max, but because of the negative, the max and the min switch. So I'm starting at -2. I go to 0 at my first pi over 8. I go up to 2. At my next pi over 8, I go back to 0 at my next pi over 8, and I go back to my minimum at my next pi over 8, which is at pi over 2. Okay, so this is essentially what you have. I never draw these very well. It's hard to draw it on this little on this here, but I'll try that again. Let's see. So you come up and down and back. It should kind of go more like that. So that's basically what that one cycle of that graph looks like. And then I can continue on with that. So if I divide it in half and I divide it in half again. So I'm at my min, then I go back to 0, and then I go up to my max, and then I go back to 0, and then I go back to my min. And then I can do that again. So divide it in half, and then divide it in half again. So I go back to 0, back to my max, back to my 0, back to my min, back to my 0, back to my max, back to my 0, and back to my min. Okay, and so once you have all those points, then it's just sketching the graph. And you probably will do a better job at it than I will. But I just want to give you the general idea of what it's going to look like. Okay, and so that's what it would look like from 0 to 2 pi. You can fill in the rest from 0 down to -2 pi. Again, you're just going to follow that pattern all the way through. Okay, let's look at the next one. The next one, we're graphing y equals sine of 1/2 x. So our amplitude here is just 1. Notice there's nothing written in front of my trig function, so my amplitude is 1. My frequency is 1/2, so I'm only completing half of a cycle from 0 to 2 pi, which means my period is 2 pi over my frequency, which is the same as 2 pi times 2, which gives me 4 pi. So I would complete one cycle in 4 pi radians. Notice my graph only goes out to 2 pi, so I'm only going to complete half of a cycle in 2 pi if the whole cycle would take 4 pi. Okay? If I do my period divided by 4, so 4 pi over 4, excuse me, that gives me my key values at every pi radians. So again, think of your sine curve. Your sine curve does this. 0 max, 0 min, 0. Okay, 0 max, 0 min, 0. So if I'm starting at 0 and at pi, because that would be my next interval, I'm up at my max. and then another pi radians puts me out at 2 pi, I'm back at 0. So you'll see here that the only thing I'm graphing is this. Okay, that's all that I end up with from 0. Let me erase that little piece there. From 0 to 2 pi. And so if I went back this way, the same thing would happen. Oops. This should be a little bit straighter, but I think you guys get the idea there. So that is how you would graph y equals sine 1/2 x. That is actually one complete cycle over 4 pi radians. Negative 2 pi to 2 pi is 4 pi radians. Okay, the last one on there is y equals 3, or sine of 3x. So again, my amplitude is 1. My frequency is 3, which means my period is 2 pi over 3. Okay, so my period is 2 pi over 3 radians. That's how long it's going to take me to complete one cycle. So again, to figure out how I set up my intervals, because this one doesn't seem quite as straightforward, right? Because of the fact it's not just pi or something like that. You have this fraction in here. So I'm taking 2 pi over 3 and dividing that by 4, which is the same as 2 pi over 3 times 1/4, which is 2 pi over 12, which is the same as pi over 6. Okay, so every pi over 6 interval is where I'm hitting one of my key values. Again, your sine graph, like this, 0 max, 0 min, 0. And if you notice, right, pi over 6, if you remember, that's just 30 degrees. And if you notice, each 90-degree section is divided into 3. So this is 30 degrees, 60 degrees, 90 degrees. 30 degrees, 60 degrees, 90 degrees. Does that make sense? So this right here, pi over 6, this would be pi over 6. So each of these little tick marks that are already on there are every pi over 6 radians. So if I follow my pattern, I start at 0. My amplitude is 1, so I'm going 0 max, 0 min, 0. Okay, so 0, then max, and then 0, and then min, and then 0, and then I'm back at 0. So 0 max, 0 min, 0. So if I were to connect those, I end up with something that looks like that. Now, notice the frequency was 3. That means the number of cycles I complete between 0 and 2 pi. Well, I completed 3 cycles. Here's one cycle, here's a second cycle, and here's my third cycle. Again, you can carry that through, all the way through to the negative side, out to negative 2 pi. And because it says to graph it over there, I didn't do it in one of the problems just in the interest of time. But you end up having this nice, pretty curve like that. So that's how you can go about doing these. Me, personally, I like it this way. It's very succinct, makes sense. The book, I think, explains it slightly differently. It might be kind of the same. You could go and look online and find other videos. There's lots of different ways that people approach it. I've just found, in all of my experience, that this seems to be the most straightforward way of doing it. So until I see you guys next time, hopefully this helps, and I will see you all later. All right, take care, everybody.